Hello everyone and welcome to this capsule. In this capsule we're going to talk about attention layers and introduce transformers. The transformers architecture looks something like this, which is at first glance kind of daunting, but we are going to go deep into each step, such as how to encode the inputs, what multi-head attention is, and kind of demystify and make it digestible. First, look at the applications of transformers. It's been applied mainly in NLP. That's what powers BERT, GPT, and other large language models. But they've also been applied to other areas and tasks, such as computer vision. In fact, the vision transformers that you see here produces state-of-the-art results on image classification, object detection, and instance segmentation. So much so that this multi-headed attention has become an integral part of most deep learning architectures. One of the most prominent examples of the use for transformers and attention layers is Stable Diffusion, where, as you can see, the orange boxes here are attention layers. The applications of Stable Diffusion, which were introduced in 2022, include bounding box to image generation. In this example, if we set a bounding box for tree on the top of the image, the computer will generate a scene that contains trees at this location. And let's say we want to produce trains at this bounding box. Stable Diffusion is able to generate realistic trains with some variation. So every train is different. Train will be produced exactly at this location. So that's one of the interesting applications of Stable Diffusion. Another one, which probably is the most famous use case, is conditional text to image generation. So if we say a basket full of cherries, it'll produce realistic looking cherries. If we say children playing football, it will also produce a realistic image of children. Another important application of Stable Diffusion is super resolution. If you use an algorithmic approach like bicubic interpolation, you see that the image will become blurry. But if you use Stable Diffusion's super resolution, it will create high quality super resolution images, as you can see from the cat's face or from this car's wheels. Another interesting use case, which is mask to image generation. So in this case, if we fine tune a Stable Diffusion model with these masks and say the code purple is, let's say, cloud, this shade of green, the dark green, is sky, kind of this light green is mountain, and train the model on these masks, it will be able to generate realistic looking scenes that will contain clouds, where the cloud mask is, mountains, where the mountain mask is. One application is in painting. Where we want to remove a certain object from the image and replace the background with contextual information from the neighbor pixels, so that the empty pixels will look realistic. So you see some examples here. These are useful for applications such as image editing in Photoshop. And as you can see, let's say in this example, Stable Diffusion does a really good job. Apart from computer vision, transformers have been applied to speech as well. One of the most recent architectures is called BARC, which is a text-to-audio model. It's called a universal text-to-audio model that uses transformers. It supports multiple languages at the same time. And in this example, if you choose unconditional, you can actually pass it text from different languages. So I gave it a Chinese text, an English piece of text, followed by French and English. So let's take a listen to it and see what it did.
你好, I am a transformer model. Excusez-moi, mes amis, my name is Bart.
So as you can see, not only it's really humanistic and natural sounding, but at the same time, that's one of the first developments in AI where we can generate in one single prompt multiple languages.